Factoring a polynomial part 2. So now I'm going to show you other techniques for factoring polynomials. I'm going to start by showing you the difference of two squares, which was briefly mentioned in a video on rationalizing the denominator. So essentially the way the difference of two squares works is when you see that you have some number squared minus some other number squared, you can factor this as a plus b times a minus b. So what does this mean? It means you've got a square number here minus another square number. So this is the difference of two perfect square numbers. And this is equal to the first term here, a, plus b times a minus b. Let's try a numerical number just to see how this works. So example, if I give you x squared minus 25, then immediately you should recognize that this is the difference of two squares. Your a term here is your x term. Your b term is not 25, it's 5 squared. So we can rewrite this as x squared minus 5 squared because 25 is 5 squared. Now you can clearly see that your b term is 5. So when I factor this, I get x plus my b term 5 times x minus 5. So there we have x squared minus 25 factored here. This is the difference of two squares. The reverse is true if I multiply a plus b times a minus b, and these two brackets are what we call conjugates. The only difference between these two brackets is the sign between the two terms. This is called conjugates. Multiplying these two brackets together will give you the difference of two squares. So if I go backwards in this example, foiling these two brackets together gives you x squared minus 5 squared. Now, a perfect trinomial, a perfect square trinomial. So suppose you have a plus b and I square this. What will it look like? Well, it's just a plus b times a plus b again. That's what the square means. It means the bracket multiplied to itself. Now, foiling this, what we get is a squared plus 2 times a times b plus b squared. So go right ahead and FOIL this if you are not sure how I got this 2 times a times b. FOIL it, you'll see that you get twice a times b, and you group the terms and it gives you 2a times b. Now, this here is a perfect square because whatever is inside this bracket gets squared, so we call this a perfect square. And what it gives us is this trinomial over here. Similarly, if I have a minus b, squaring this gives you a squared minus 2ab plus b squared. So whenever you see a squared plus or minus 2ab plus b squared, then you know immediately you can factor it as either a plus b squared or a minus b squared. Let's do a very quick numerical example of this. If I have a plus 2 squared, well, this is going to give me excuse me, a squared plus 2 times a times 2, so that's 4a, plus 2 squared is 4. So when I see a squared plus 4a plus 4, I know immediately that I can turn this into a plus 2 squared. In fact, I can write this as a squared plus 2 times a plus 2 squared. So I'm going to use a different color. This 2a here is like my a times b, where a is my a and 2 is my b. This 2 in front here is like this 2 over here. Whoops, I'm using the wrong example. So this 2 times a is like this a times b. And this 2 over here is like this 2 over here. My b squared, we said b was 2, so I have 2 squared. So this I can see is in fact just a plus 2 squared. It's a similar case if you have a negative. If you have minus here, then you would have a minus b squared.